Hello friends, welcome to this lecture. In last lecture we have seen the various contents of this particular course water supply engineering. Today we will start with the content itself. Today we will see the various aspects associated with the water supply engineering. In this lecture today we will try to know the various sources of water, what are the various water supply schemes, design period of that. Now, as you know that friends, there is a stress on the world water supply. Increasing number of people relying on the limited runoff produces low per capita availability of water, which leads to the water stress. So, at present, the word is water stress. You know that we are having the limited access to the drinking water quality. Water stress comes when the volume of reliable runoff per capita drops below 60,000 cubic feet per year. Water scarcity occurs when per capita water availability falls below 35,000 cubic feet per year. So these word figures are there. If you see this red color, okay, which is having the stressed area, water stressed area. What are the water sources? If you see the raw water source, the various sources of water can be classified into two categories: surface water sources such as ponds, lakes, streams, rivers, storage reservoirs, oceans, generally not used for the water supplies at present. Then again, subsurface sources are there, or which are also called as underground water sources, which are springs, infiltration wells and tube wells. Another way to classify the water sources is again rainwater, oceans, rivers, lakes, streams, ponds, and springs are the natural sources of water. Then dams, wells, tube wells, hand pumps, canals, etc. These are the man-made sources of water. If you see the worldwide water figures, okay, you see the 97% of total water is saline water, and fresh water is available only the 3%. Then again, if you want to go in more detail, the groundwater is 30.1%. Then ice caps or glaciers, you can say these are the 68.7%. Then surface water, you can see it is a 0.3% and other is a 0.9%. Then in terms of rivers, swamps and lakes, if you go, the lakes are 87%, okay, rivers are 2% and the swamps are 11% if you see the surface water there. How much water is usable? Okay, all water on the earth, if you see, okay, unusable water is 99% and water usable by human is 1%, and groundwater is 99%, lakes are 0.86% and the rivers are 0.02%. So here you can understand what care we'll have to take to protect all the water resources, and how the water will have to use carefully. So here it is an alarming situation. World water crisis again. 1 in 5 people do not have access to the safe drinking water. Every 15 seconds, a child dies from the water-related diseases. Some young children and women trek up to 6 miles a day in order to collect the water from for their families. Now this is here we are getting the tap water at our home, but there are many countries are there, many places are there. There is no safe water supplies, and very critical situations are there. Much of the world's drinking water is contaminated. So this situation you also know and possess serious health threats. You can see there are frequent fish deaths are there. Then you can see the water conditions because of the waste disposed in the water. So this is becoming a very alarming situation now. Now because of this there are various water related diseases, and because of this we are prone to the danger situation. So diseases because of the bacteria and viruses are the diarrhea, E. coli, especially hepatitis A and E. Okay, arsenic causes salmonella typhi and virus. Okay, Psicocymasis, Shigella, then adenoviruses, incidental diseases, Yersinia, enterovirus, then worms, enterocolitica, then rotavirus, hepatitis, cholera, malaria, trachoma, typhoid, fluorosis. These are the various diseases which are because of the bacteria and viruses. A cure for the global problem with the high tech treatment systems for the rural areas, developing countries usually are expensive and difficult to construct, require expensive mechanical equipment, require expensive and dangerous chemicals. So here we'll have to also study what are the safe methods to treat the water. What are the objectives of the water treatment? Okay. To remove the color, dissolved gases and objectionable color of water, to remove the objectionable taste and odor, to remove the disease producing microorganisms so that water is safe for the drinking purpose, to remove the hardness of water in case of the groundwater source, to make it suitable for a wide variety of industrial purposes such as steam generation, dyeing, etc., to remove disease producing microorganisms so that water is safe for the drinking purpose, to remove the hardness of water in case of a groundwater source, to make it suitable for the wide variety of industrial purposes such as steam generation, dyeing, etc. What are the uses of water? The water is used for the so many purposes: for drinking, cooking and washing, for bathing, for swimming pools and water games, fountains and cascades that for the display, watering of the lawns and gardens, air coolers, dishwashers, for firefighting, industrial operations such as steam generation, irrigation, sanitary purposes. Now, what are the elements of the water supply scheme? So, again, we are going to go in detail, but just we'll have the introduction today. Now, we'll have to see selection of the water source, river, lake, or any open water source. Remember, tube well, these are the various water resources are there. Collection and conveyance of the raw water, intake works, pump house, rising main, etc. Treatment of the water, okay, multivariate treatment to remove the different types of impurities and pathogens. For example, if you see the water treatment process, there are various units are there which are treating the water and removing these impurities. Pumping and storing of the treated water in the ESRs, distribution network pipes is needed. This is the flow diagram which is showing how the water supply scheme functions. Okay, surface source of water, intake works, pumping, rising main, water treatment plant, actually where the water is processed and treated, elevated service reservoir where the water is stored, and distribution system. After showing the proper distribution system is necessary so that water can be served to the society. These are the various layouts of the water supply scheme. If you see the village, in the villages limited treatment is given. From the open well, the pump house is there, it is stored in the elevated service reservoir and it is distributed. This is a distribution area. But in the urban area or in the city water supply scheme, you can say this is the water source. From the water source, it is from the intake well. From intake well it is pumped. Intake well it is taken to the jack well. In the jack well, the pumps are there. Then there is in between the rising main is there, which transfer the water, you can say, which convey the water to the water treatment plant. Then flash mixer, coagulation and the flocculation process, clarifier, then rapid sand filter, chlorination, filter water tank, then elevated service reservoir and the distribution. Then distribution is there. So this we are going to study every particular treatment, you can say, treatment unit that we are going to study in detail in coming lectures. Then data to be collected for the design of the water supply scheme. So in that, sources of raw water, choice among the alternatives, reliability of throughout the year. So it is expected that the water source should be perennial. Quantity of the water required, which depends upon the population to be served, population forecasting, census data, Water demands: domestic, public, industrial, fire, etc. Design period: 30 years is the common. Quality of water: analysis of water line of treatment is to be decided by the law, raw water quality. Survey data: topographical maps, plan or map of the city or town for knowledge of the existing structures and roads. What factors are there which are affecting the design period? Design period is affected because of the useful life of the components of the water supply scheme. For example, pumps are there, intake structure, rising main, pipe distribution, network will decide the design period. High design period has to be adopted if there are difficulties in the future expansion. Ability of funds: less funds, there are less design period. Then rate of interest on the loans: larger the rate of interest, smaller the design period, and the vice versa. This is also the important aspect. Rate of increase of population is lower than higher, then higher design period is adopted. Quantity of water is water available: if required quantity of water is not available for longer periods, then lesser design period shall be adopted. Now you can see these are the design period. In coming lectures again we are going to study in details. Remember, for example, storage by dams is the 50 years design period. Infiltration works 30 years. For pumping units, for the pump house, which is especially civil works, it is 30 years expected. Then electric motors and pumps, 15 years is the design period. Then water treatment units, now these may be a flocculator, this may be coagulation unit is there. Okay, these are having the 15 years. Then pipe connections to several treatment units and other small appurtenances, 30 years. Raw water and clear water conveying mains, 30 years. Clear water reservoirs at the headworks, balancing uh, and the service reservoirs. Overhead and groundwater level, so it is 15 years. Distribution system, 30 years. So likewise, when you are designing the water supply scheme, you will have to also go through the various parameters to design that. For example, population forecasting, then this, as we have seen, the design period. Now the various methods of the population forecasting, then how the design is carried out, actual design is carried out, then how the capacity of the various units is decided, then what treatment technology decided, that we are going to study in details in coming lectures. So today we will stop here for this particular lecture, but all of you are requested to go through the content, and actually we are also giving the necessary notes and associated assignments regularly to you. So you are requested to tune up yourself with the studies. So today we'll stop here. Thank you very much.